When we fly SOFIA to New Zealand, we are providing access to astronomical objects that we don't have access to here in the Northern Hemisphere, a different part of the sky. The Magellanic Clouds, Southern Cross.
One of my favorite objects in the southern sky is the center of our own Milky Way galaxy. There's a supermassive black hole there, stars orbiting it, gas clouds around it. SOFIA will be able to observe these and study the center of our galaxy.
SOFIA stands for Stratospheric Observatory for Infrared Astronomy. It is a jumbo jet, a Boeing 747 aircraft that has been retrofitted with a 2.5-meter infrared telescope that was built by our partner, the German Aerospace Center. It flies above 99% of the water vapor in the Earth's atmosphere, and that is the location that is required to do infrared astronomy.
SOFIA has unique capabilities. It can detect light in a part of the electromagnetic spectrum that can't be detected by any other observatory.
SOFIA does a lot of unique science. We look at the formation of stars. We also study the formation of planetary systems around stars. We also will do planetary science within our own solar system. And the Pluto Occultation is a perfect example of that. Conducting an observation of an occultation is probably one of the more challenging missions that SOFIA can do. An occultation is essentially a situation where a planet, in this case Pluto, is passing in front of a background star, kind of like an eclipse. And when Pluto does that, we will be able to see the effects of the light as it passes through Pluto's atmosphere. And we can use that light to determine what is happening in Pluto's atmosphere, how deep it is, whether or not there's winds, and help characterize the situation. The shadow of this occultation is going to occur in the middle of the ocean. There isn't another telescope that can take advantage of this opportunity. The aircraft is moving at about 500 miles an hour. The shadow that is being cast on the surface of the Earth by Pluto is moving at orbital velocities. We will really need a teamwork effort in order to successfully observe Pluto during its occultation. On the night of the observation, while SOFIA is in flight, there will be a team of observatories that will help SOFIA. The Anglo-Australian Telescope, Lowell Observatory, the Naval Observatory at Flagstaff, the Discovery Channel Telescope will be making last-minute observations of Pluto. They will provide observation data to MIT, and MIT will update the predictive model of where the shadow of the Pluto occultation is going to be on the Earth. We will receive that update, we will modify our flight plan, and position SOFIA where it needs to be to intercept the shadow. The data that SOFIA is going to collect when we observe the Pluto occultation will help characterize the atmosphere on Pluto. And it'll also provide data that could be used for calibration, a ground truth source of data that will enhance the New Horizons mission in the following days.
NASA New Horizons flyby July 14th of 2015 is just 2 weeks after this stellar occultation that SOFIA will observe. That is timely. It means that we can use the data from SOFIA to correlate and corroborate the measurements that are made by New Horizons when it goes up close and personal 2 weeks later. We'll probe Pluto's atmosphere to extreme low levels. SOFIA's infrared capability is the only type of instrumentation that can equal that measurement. So by having a measurement of Pluto's atmosphere from another platform, from SOFIA, taking with almost the same type of sensitivity, can help us interpret the results that the New Horizons spacecraft is going to make 2 weeks later.
In order to successfully execute a deployment requires a tremendous amount of planning. We've been planning for this deployment for several months, and in some cases for almost a year. Essentially what we're doing is we're taking all of our home base operations and we're transplanting those operations to Christchurch, New Zealand. The last time we were in New Zealand, we operated with a single instrument, and we were very successful in doing so. This time around, we're going to increase our science instrument complement by a factor of 4. We're going to take 4 different instruments. We're going to change them out in location. We're going to support all of those instruments. And so the tremendous amount of logistics, detailed planning, that is required to successfully conduct those operations that we normally do at home is quite challenging.
Astronomy demands that we develop very sensitive cameras, very sensitive optical systems, the ability to detect faint sources amongst a noisy background. And once we have that capability, we can apply it in other areas. It's been used in medical imaging, it's been used in homeland security. The most important reason we study astronomy is to understand our place in the universe.
Looking forward to a very successful Southern Hemisphere deployment in the next few weeks.